Introduced by Niels Bohr in 1913, the Bohr model shows the atom as a small positively charged nucleus surrounded by electrons that travel in circular orbits around the nucleus. Electrons orbit the nucleus at set distances. The energy difference between the first and final orbit is emitted by the atom in bundles of electromagnetic radiation called photons. With his model, Bohr explained how electrons could jump from one orbit to another only by emitting or absorbing energy in fixed quanta. For example, if an electron jumps from one orbit closer to the nucleus, it must emit energy equal to the difference of the energies of the two orbits. When the electron jumps to a larger orbit, it must absorb a quantum of light equal in energy to the difference in orbit. Now drawing a Bohr's model, you can see the different orbit levels and the electrons that are on them. The electrons are circling the nucleus on their orbitals just like Bohr thought. The ground state is the lowest energy level of an electron in an atom. An excited state is any level higher than the ground state. When an atom gains energy, it moves to the excited state, and when an atom loses energy, it moves down to the ground state. As you can see in this model of the hydrogen atom, when an electron falls from the fourth energy level to the first, radiation in the UV zone is being given off. You can also see that if an electron falls from the sixth energy level to the third level, radiation with a wavelength of 1094 nanometers is being given off. In the clip you just saw, Haley was the nucleus in the atom, and Jasmine and Riley were the electrons rotating around her in a perfect circular orbit. This is the main incorrect point in Bohr's model. The electrons do not move in a perfect circular motion. They do not move in any perfect type of motion. They move randomly throughout the atom, as you are about to see in another example. Bohr's model also violates two more important things. It violates the Heisenberg uncertainty principle because it considers electrons to have both a known radius and orbit. The Heisenberg uncertainty principle states that it is impossible to know the exact position and velocity of a particle at the same time. It also makes poor predictions regarding the scope of larger atoms. The model is only of hydrogen, it does not give other examples of different elements' atoms.